Hello guys, welcome back to a new video on matrix math / linear algebra. Today we're going to be starting on simultaneous linear equations. And these are pretty cool and end up actually being rather important because they are in a lot of ways how you end up doing computations. But today we're just going to kind of introduce linear systems and what simultaneous linear equations are. So let me go ahead and get into it here. So what a linear equation is basically some matrices that can line up to be an equation. And it looks like my computer wants me to do something. Alright, so trying to think how to explain this without overcomplicating it. Let's say we have, let's just start with a few examples. So I'm going to use my draw tool here. Oh, that's a huge circle. We don't need a circle that big. We'll do it about this size. Okay. So say we have a matrix A, and it is a 4 by 4. I don't know. We'll just put some random stuff in it for now. 0, 1, 2, 3, 2, 7, 6, 4. More ones down here. That's an ugly matrix. So don't worry about it. It's just a 4 by 4 matrix. Hold on. I'm explaining this all wrong, I think. No, we're good. This is right. So you have a matrix with a bunch of variables in it. And then you have another one that is just a vector. Let's call it x in this case. And this is what your unknowns are. And this is typically a column vector that will look like something like this. X, Y, Z, and then W. And then you have a result vector that looks something like this. It's just usually called B. And we just have the results. We'll have B1, B2, B3, B4. Now, as you might have noticed with most math stuff, it doesn't really matter what you name it as long as you understand what your names mean. So go with what you will here. But basically what ends up happening is you take each row of this matrix and you put the X plus the Y plus the Z plus the W. And it has to add up like that. So it's like X plus, well, 0 is going to be no Y's. So it'll end up being plus Z. And then this 2 will be the W, plus 2W. So this row here, this top row, would turn into the linear system looking, or a linear equation looking like this. X plus Y plus 2W. And I hope you understand that, but just to be super clear, this 1 goes with this X, this 0 goes with this Y. That's why there is no, oh, this should be a Z. Little error there on my part. You won't see the Y since in the Y slot it's a 0, so there's just nothing there. But if you want it to line up, sometimes you'll have to leave a spot there where it is. And I did it again. I put a Y there again. Alright, it's a Z. Okay, so 1 goes to the X, 0 goes to the Y, and this 1 goes to the Z, and then this 2 over here goes to the W. And then what we get here is it equals whatever's over here. So it'll equal, well, B1. And while you can't solve this on your own, you could do some substitution, which we will talk about in the next video as we learn how to solve these. But right now, we're just kind of figuring out how to organize them. So if you wanted to do this next row, we got a 4, a 1, a 3, and a 2. It would look like 4x plus, let's see, 1y, which is just y, because it's implied that there's a 1 in front of it, plus 3z plus 2w. And that will equal b2. And so on. You could do that with this next row and this next row. This one's all 1, so the very last row is just all 1, so it would be x plus y plus z plus w equals b4. And this one before it would be 7x 6 plus 6y plus z plus w equals b3. So dot 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 dot. Yeah, that's kind of how you set them up. Let me just read a few things here. Let's see this. This solution over here is a set of scalars. So you want these to be actual results, and a scalar is usually just a single number. So you don't want these b ones to end up being another big equation at the end. You want to actually solve them is the point. But as we will find out, you can't always fully solve them, so sometimes you just have to get as far as you can get and call it what it is. Alright, let's make a new layer here. Oh, apparently I was drawing on this background layer some. So I'm going to just make a little correction here. And we'll delete those layers. Okay. And we'll delete this layer too. Okay, so let's move on here. We got just a few more things to show you, but that is really the gist of it, is just understanding how to set them up. So let's do a little example. Some of these are really easy to solve and you can kind of figure them out. The other ones are a little more difficult. So we're going to do example 1 here. That's an E1. Let's say we have this system and they want us to convert it to matrix form. We have x plus let's say 2y, we'll do a minus here, minus z plus w, and we'll say equals 4. And then the other equation we have is x plus 3y plus 2z plus 4w equals 9. That's a 4, that's a 9. Okay, hopefully those are readable on the screen. So if you want to turn this into a matrix, we basically do the reverse of what we did before. We'll call the matrix just these numbers in front of the letters. So it's going to be a, let's see, a 2 by 4. 2 rows, 4 columns. So it looks like we got a 1, a 2, a negative 1, and a 1. So a 1, a 2, a negative 1, and a 1. And then on this next row, we have a 1, a 3, a 2, a 4. 1, 3, 2, 4. And it looks like the XYZ is pretty standard. So we will call this, we'll put a comma here. We'll call just the X what it is, X, Y, Z, W. X, Y, Z, W. And then we have the solution, which we're going to call B, and it is going to be these numbers, 4 and 9. 4, 9. And there we go. We have successfully turned that to this linear system right here of equations into matrix form here, and that would be the answer if you were just asked to convert it to matrix form. So these can get more complicated. There can be more rows. If any of these are missing, like if there's just no z here, it's assumed that there was a 0 in front of the z, so it would be a 0. So just so that's clear. And now what you'll find as you try to solve these is sometimes there will be no solutions, sometimes there will be just one solution, and sometimes there will be multiple solutions. So there's some different things here. If there are no solutions, the system is called inconsistent. So I'll make a new layer for that, and we'll just do some typing here. So no solutions equals inconsistent. And we want to say if there are solutions, that means one or more, I'll put 1 plus there, then it is consistent. So we have some different systems there. And now there's one more thing about the answer. that B, let's see here, this B, all right? Now, what we want to say about that is basically, let's go back to this tool. Let's see, if B, so B is a vector. If B ends up equaling 0, which means everything in it is 0, then we get a, let's see, we get a homogeneous function. Then it is, we'll call it homogeneous. I hope I'm saying that right, and spelling it right. There we go. Is that right? Yeah, that's right. If B is not equal to 0, I don't have a not equal, so I'm going to use the C++ syntax of apostrophe there. So if B is not 0, that means there's something in that vector that is not 0, and it can be anything. Then the system is called non-homogeneous. Okay, so that's the very first intro to these linear systems equations. The next couple of videos we'll be going over how to solve them, and we'll also be going over the best way for computers to solve them in case you're programming these sorts of things. All right, thank you for watching. Hope you all have a great day. Take care of yourselves and stay warm. I don't know about you guys, but where I'm at, it gets really cold. So, peace out.